Okay, for number 9, you're given a function, it's a parabola, and you're given a graph of it. And I do see the graph, it's certainly a parabola. You probably, I'll answer the question, but you could probably answer some of them now. If they're there, I mean, I could certainly tell you what the y-intercept is. What's the y-intercept? And it could be a question, who knows? The y-intercept would be where x is 0, the y would be 10. There are no x-intercepts, so I'm just looking at the picture, by the way. I'd say none. We've done this before. I probably could write the vertex down pretty easily as well, by the way. And certainly looking at it, I got an idea where it is, but let's go through that. It's going to be what? Let's be careful about this. It's going to be, the opposite of the b, which is minus 2. Minus 2 is 2. Divide by 2 is 1. So I know it's at 1. And what's the y-coordinate going to be? We can get 1 minus 2, which is minus 1, plus 10, which is 9. So the vertex over here, this is the vertex, occurred at 1, 9, which certainly, it's a nice picture. I can look at that and probably could have got that just by looking at the picture. Let's see what the questions are, though. The question may have nothing to do with what I just did, right? The question's as follows. Use the rational root theorem to list the candidate rational roots. Well, let's look at it. Not too bad. This is A. The candidate rational is plus or minus the factors of 10, which would be 1. 1's a factor of 10. 2's a factor of 10. 3's not. 4's not. 5 is. And 10 is. And then the factors of the coefficient on the quadratic term, which is simply 1. So I'll limit this amount for you. Plus or minus 1, 2, 5, and 10. All right, put a box in it. It's letter A. And let's go to letter O. Test the candidate roots to see which one are roots. And the bottom line is you're looking at it, I would say for B, none. None work. Now someone says, how do you know that? Did you test them? No, I know that by looking at the picture. So, f of 1, f of minus 1, f of 2, f of minus 2, f of 5, f of minus 5, f of 10, f of minus 10, none of them are going to produce 0, so none work, all right? What's the other thing says? Use the quadratic formula to find the roots. Let's do that. Look at the key later, by the way. I'm on to C. Quadratic formula, relatively simple. X equals, let me tough. Let's see, 2 plus or minus, these are going to be complex, by the way, 4 minus 40. X equals 2 plus or minus, well, 4 minus 40 is minus 36 over 2. I'm going to keep working on it, don't I? X equals 2 plus or minus 6i over 2. X equals 1 plus or minus 3i. Let me write that down for you. We found the roots. I'll put them in list form. I'll put down 1 minus 3i. The other one is going to be 1 plus 3i. Okay, I want to encourage you to look at the answer keys to make sure you're getting the answers. I'm not sure I'm there yet. Oh yeah, factor it. I think I can factor it now. And let me write this down. This is going to be letter D, by the way. So f of x factored, relatively simple. It's going to be x minus each root. X minus 1 plus 3i. And then it's going to be x minus 1 minus 3i. All right, let's take a look, see if we did it. Let's see if we got these guys over here. And yeah, I might have written it down a little differently. Plus or minus 1, 2, 5, and 10. I got that part done. None of the candidates work. Hope you remember I did that. You need to use quadratic formula. They said x equals 1 plus or minus 3i. I got that. Let's see if I got the factorization of it. And I think that's written over here. X minus 1 plus 3i and x minus 1 minus 3i. Yeah, it's looking good. We're fine. Thank you.